Hi, I'm Dave Breckell. I'm the Marketing Development Manager for OMRON here in the UK, and I'd like to just give you a little introduction to our K6 family of motor condition monitors. These are devices that are designed to be retrofitted onto a motor, and essentially they can pick up a fault or a failure condition long before it actually causes damage or stops your machine. Obviously, we're all trying to reduce unplanned downtime. Typically in a factory that can cost upwards of £5,000 an hour, and unplanned downtime can be well over 20 hours a week. What we have with the K6 is it's basically an edge-based system. So we have a motor with the monitors on it, and all the actual control and the monitoring is done locally through the device in the panel. In this case, we have two devices for an electric motor. The first unit here is measuring vibration and temperature, and that's simply a small probe that you mount on the motor itself, and should there be any faults occurring, if the motor gets too hot, if there's an issue with the load and it starts to shake, it can measure the acceleration and the G-forces to give you a warning. The second unit that we have here is our current analysis model. This is a very clever piece of kit that's analysing the current of the waveform of the current going to the motor. What this can do is actually pick up not only issues with the motor itself, for example, your bearings might be breaking down, you may have bearing scratch, but we can also pick up issues with any load connected to it. So it could be that there's a misaligned load connected to the motor, it could be a submerged pump with cavitation, etc. The thing to stress with these is because essentially it's edge-based, you can start small, so we would look at maybe one or two machines where you have the highest risk of either downtime causing a lot of stoppages, maybe a motor that's on a long lead time. This could be retrofitted on top of your existing control system. The units themselves have an Ethernet IP, so we can feed this back into the PLC. We can feed it into an OEE system, for example, for long-term condition monitoring. As well as having the data output, we have a series of fixed outputs, so it can simply just be wired into, for example, a tower light or an alarm output when it reaches some predetermined fault levels. So we've got two units here. This is measuring vibration and temperature and current analysis. If I start the motor up here, we have an unbalanced load on the end. You can see that starts to come up already, it's vibrating. You can see this is measuring the vibration, the current. We have an amber here because essentially it's in a warning condition because of the vibration on the motor itself. As I speed it up over time, the vibration will become too high, it will go red and give you an alarm output. This can then be remotely reset.